Hey, grade 6s, we're talking about equations and solving equations. And if you look at the word itself, it sort of tells you what it is. Look at this part of it. Okay, the first part looks like equal, and that's what an equation is. So if we look at our definition, an equation is a math statement where two sides are equal. So let's look at a few of these examples and see if we can figure out whether they're actual equations or not. So the first one, 42 plus 3 minus 4. Is that an equation? Do you have two sides that are equally balanced? Well, nope. And there it goes. What about this one? 35 minus 10 equals 25. Do you have two sides that are equally balanced? Yes, you do. And that is an official equation. 98 equals 100 minus 2. Do you have two sides that are balanced? Yes, you do. What about over here? 45 is equal to 9 times 5. Two equal sides? Yep. 67 minus 23 plus 3. Is it an equation? Do we have two equal sides? Oh, no, it's going away. Oh, and what about this order of operations question? Do you have two equal sides here? No, you don't. So out of those 6 examples, we've got 3 that are official equations. Well, let's go into how to solve these equations. So if you're given a question like 172 equals something plus 39, you have to have some sort of strategy. And today I'm going to be going over 3 different strategies that you can use in order to solve it. And the first one is called guess and check. So the first thing you want to do is look at 172 equals something plus 39. So how I would start is maybe just add 100. So if we go 100 plus 39 and we get 139, well, that's not quite 172, so it's too low. If we go on to 131, and how I came up with 31 is I was thinking, okay, 31 and 39, that gives me pretty close to 72. So 131 plus 39, that gives me 170. We're just a little low there. That not right on, but it tells me I need to go 2 more. So 133 plus 39 is 172. So really with the strategy, all you do is you pick numbers out that seem reasonable and you keep moving around until you get the absolute right answer. Guess and check. It's a great strategy. You can use it to solve equations. Let's try one more. 194 equals something plus 42. Another strategy that you can use is called the inverse operation. And with mathematics, inverse operations are operations that go sort of hand in hand with each other. You've got addition and subtraction. We've seen that in order of operations, that they're sort of companion operations. And then you've got multiplication and division are inverse operations of each other. So what would the inverse operation of addition be? Subtraction. So what we can do is we can turn this number 194 equals something plus 42, we can turn it into a subtraction question and we can actually figure it out using that way. So we'll take the 194, we'll minus 42, and we end up with 152, and that is indeed our answer. Let's look at another example. Something divided by 8 equals 42. So what you could do is you could multiply 8 times 42 to get the answer that would be up front. And indeed, that's what we can do to find out the answer is actually 368. Let's look at one more problem-solving strategy that we can use. And this one you won't find in the book, but I like to call make a simple example. So it sort of goes hand in hand with the inverse operation idea. If you have a question 234 equals something minus 56, you could make a simple example in your head. And with addition and subtraction, I like to use the example of 5 or 2 equals 5 minus 3, or 2 plus 3 equals 5, because it's very simple and it's very clear to me and I can think out all the different aspects of it. So with this question, 234 equals something minus 56. If I substitute these numbers, 2 equals something, which will be 5, minus 3. So now I ask myself, okay, I need to know what the 5 is. So how can I use 2 and 3 to get 5? Well, I have to add them. So that's what I do. 2 plus 3 equals 5. So now I say, okay, if 2 in my example, or if 2 in my simple example represented the 234, and if the 3 in my example represented the 56, then my operation, when I use the original question, will be 234 plus 56 equals whatever the answer is. So see how I just took the 2 represented the 234, so I just put it here. So there's the 234. I add the 56. The 56 was represented by the 3, so it's there, and then I'll get the answer. And I just have to add that up, and I find out that my square is actually equal to 290. Let's do one more example. As I said, the inverse operation of division is multiplication. So you think of a simple example with division and multiplication, and I usually use the example of 6 divided by 3 equals 2, or 2 times 3 equals 6. And so I plug these into my answers, and I say, okay, if I take something divided by 6, so if my answer I know is going to be 6, divided by 3 equals 2. Okay, so I don't know the 6 yet. How can I use 3 and 2 to get 6? Well, I use the inverse operation. I multiply. So I go 3 times 2 equals 6. And now I've got a pattern to use in my original question. So the box is going to go at the end, because that's where the 6 was. The 3 represented the 6, so it's going to go in front. And the 144 was represented by the 2, it's going to go in this place. So now I rewrite the question. There's my 6 times 144 equals my answer. And then I just have to work it out, and lo and behold, I get the answer. So there are 3 problem-solving methods to solve equations: guess and check, using inverse operation, and using a simple example. I hope that it helps explain some of the strategies we can use to solve these problems. Enjoy!